this video, we learn the basics of using R and RStudio. When you open RStudio, you might get a screen that looks like this. Eventually, we want to get 4 panes looking at us, and sometimes it's a little bit challenging. But we want, in the upper right, we want to find this environment pane. It might be minimized. You might have to play with some of these buttons here to get the environment pane showing. I like that one in the upper right. In the lower right, you'll see files, plots, packages. That's good. Again, it could be hidden, so you might have to reveal it. But this pane here is how we want to see it. This pane on the left is called the console. And the console, you can think of like a calculator. We could type in 2 + 2, and we get the result of 4. Ultimately, though, the window we're going to spend the most time in is not even shown here. And that is the script editor window. So if you do File, New File, RScript, it opens up a window in the upper left. And this is called the script editor. And we can use this like a calculator as well. But notice when I press enter, nothing seems to be happening. What you do when you work in the script editor is to get a line from the script editor to get executed in the console. You press Control Enter on your Windows computer or Command Enter on your Apple Mac. You might be tired of typing already. Let me show you a workflow you can use to reduce the amount of typing you have to do. Let's open a browser, and we're at Google. We'll go to the book's website, Causac.com, and we are on chapter 4. And as I scroll down here, you can see we get to the writing scripts using the source code editor. So I'm just going to press Control-C and switch back to my RStudio. And I can highlight these and get rid of them, and Control-V, and I copy and paste the code from the book's website right into a script that I can use. I'm unhappy down here. Sometimes we're going to want to clean things up as we go along. And why am I unhappy? Because it's got all this code I no longer think is relevant. I will press Control-L and just make it disappear. Back up in the script window, we see we now have these lines A = 2, B = 4. The equal sign, the single equal sign, is called an assignment operator. I am defining an object inside of R. That object is named A, and it has the value of 2. We see this in the environment pane. If I press Control-Enter on line 2, you can see the environment pane is updated where B gets a value of 4. And then we can do math on A + B, and it equals 6. Now, the reason we use a script window is we want to be able to reproduce our data analyses. By having a script, we can document everything from manipulating raw data all the way through to our final visualizations. Let me show you the importance of a script. I will now monkey around in the bottom left in the console, and I will redefine the value we gave to B. I'll give it the value of 26 instead of the value of 4. So now when I type A + B, I get the value of 28. I now realize I made a mistake. I didn't want to overwrite B. This is disastrous. Fear not. It is not as disastrous as it may seem. The terrible position we are in when we redefine B is not as disastrous as it may seem. Just like this guy hanging from the clock, safety is right around the corner. If we want to return to where we were, all we have to do is run all the lines in the script window. To run all the lines simultaneously, we could highlight them and press Control-Enter, and we get back to a scenario where A + B = 6. If you click Source, it will run the entire script. And if you click Run, it will just run the line or the selection that you're on. Notice you can run a partial line. I can highlight just the letter B here. And in the console, you will see when I press Control-Enter, or if I press Run, it gives me just the value of B. Even though my cursor is on line 3 here with A + B, I only return the value of the selection. If I want to return everything, Don't highlight anything on that line and press Control Enter, or highlight the entire line and press Control Enter. Now that we have this super duper script, we might want to save it for use later. So how do you save a script? You go File, Save As, and it's going to come and point me to this Documents folder. And this is where I have to say this is no good. You have to be very explicit about where you put your files. Otherwise, you're going to end up with a messy file structure. Everything's going to be disorganized. Everything's going to get lost. So let's cancel out of here. RStudio will read and write from your working directory. What's your working directory? It's any folder on your computer that you select. So let's choose a working directory. I'm going to go Session, Set Working Directory, choose Directory, and I'm going to navigate on my computer somewhere that I know where I can find things. And I'm going to create a new folder. On Windows, you right-click and do New Folder. And I'm going to call it Analytics, Enter. And then if I highlight that folder name, Folder Analytics, I can choose this as my working directory. You can see R executed a command in the console. This command says set the working directory to the Analytics folder. And now when I click File, Save, it automatically puts me in the Analytics folder, and I can give this file a name that makes sense to me. So I can save it as my first script. It will automatically get a .r extension because it is an R script. It's just a text file, but giving it the .r extension tells your computer that RStudio should open this script and the R programming language is used to execute it. Save. I now want to talk about R objects, specifically vectors and data frames. But I'm stuck with my first script up here in the upper left and these values in my environment. Things feel cluttered to me. I want to clean up. So cleaning up your environment is something you should do regularly. Keep things organized, keep things clean.
Every time it's time to go, there is one thing you should know. It's time to clean up, time to tidy up.
If I want to clear my environment, say I don't want A to have the value of 2 and B to be assigned the value of 4, I can go Session, Restart R, and that wipes out everything. Our environment is empty. The other thing I could have done is press this little broom object. To get rid of my first script, since I save it, I could just click X and it's gone. And now I have this messy console, and to clear that, we've learned the Control L trick before. Also under the Edit menu, there's a Clear Console menu option. We can click that and we start new again. File, new file. Our script. Always work in a script. Always. Very rarely will you be typing in the console. I encourage you to keep scripts and organize them. As you write scripts, you should add comments to your file. Comments are lines that the R programming language will not interpret or run. They're comments to you. They're comments to your future self and to your collaborators, so you remember what you were doing. Here's the comment for this next script. Let's learn R objects, vectors, and data frames. Let's have some musical motivation to learn about vectors and data frames. Imagine we want to store information about some great songs, great artists with their songs inside of the R programming language. We're going to store like elements in something called a vector. The C function is used to define a vector, and inside of the function, you will put, in this case, artist names, Lizzo, Pearl Jam, Paul Simon. A vector by itself doesn't get stored, so we're going to use the assignment operator, which is the equal sign, to store these three artists in an object called artist vector. And you can name objects in R anything you want, as long as it starts with some letters and there's no spaces. So similarly, we can define a song vector and also a length vector. In this case, the length of the songs. And in each case, we're using the C function to create the vector. I'm not enclosing the numbers inside of quotes. Quotes are reserved just for text, also known as strings in programming terms. Numbers do not need the quotes around them, otherwise they will be interpreted as text. Now we might want to combine our three vectors into one consolidated object. That object will be called a data frame. We use the data.frame function to create it. The data frame function consists of column names and column data pairs when we create the data frame. So the column names will be artist, song, and length. And for each one of those columns, the data that is supplied are drawn from the artist vector, song vector, and length in minutes vector, respectively. Since we don't just want to print this data frame to the console, we create an object called songdf and assign it the output of the data frame function. You can see songdf is now created in the upper right environment panel. The last thing we'll learn about in this video is functions. You've seen built-in functions like C and data.frame, and you might not be sure how they work exactly, and that's okay for now. But one way to learn how they work is to create your own function. Here we create a function that's going to take song length, which was recorded in minutes, and output that song length or duration in seconds. So to convert from minutes to seconds, you simply multiply by 60. So inside of the function, we create a temporary object called time in seconds, and we can name it anything we want as long as no spaces. And we multiply the input or the argument to that function, which is time in minutes, by 60. Specifying return time in seconds says which R object from within the function should be the output of the function. So now we have a function, min to seconds function, and if we supply the argument of song length, it will spit back the song length in seconds. Notice I can reference the column of a data frame using the $ operator, songdf $length. Using that operator allows me to quickly access any column inside of a data frame. You will see that notation quite frequently. So we print out the song lengths of 3, 6, and 5 minutes, and then we run the function minutes to seconds function on that vector of song lengths to get the result of 180 seconds, 360 seconds, and 300 seconds for our song length. The last thing I'll call attention to is that when we created this function, we passed an argument. The argument value, an argument is a term you'll learn to understand over time, but argument is a value passed to a function that the function does something with. Up here, when we define the function, look at our definition, we said there's one argument called time in minutes. We never specified that songdf $length represented time of a song in minutes, but we can be explicit about this. R allows you to either, and remember, you can use tab liberally to try to do autocomplete and save yourself a lot of typing. But here you can see, as soon as I say the min to seconds function is what I want to do, time in minutes is the first argument, and I can put any duration of minutes. Say I wanted 7 minutes to be the argument that we're converting from minutes to seconds. I can do something like this and get 420 seconds down here, which is correct. I can omit the argument name, which is time in minutes, and just pass the argument value. I'm allowed to do that. R will go in order. So if it's a function that accepts more than one argument, this is a function that only accepts one argument, time in minutes, it will assume whatever you pass to this function called min to seconds function that you created, and you created it using this assignment operator, it will assume whatever value is passed to that function represents the first argument to the function, in this case 7. And we can also do something similar with songdf $length. I can say this argument is time in minutes explicitly, and we will still get the same result as before. Functions are something you'll need to play around with and learn over time, but a function is basically a shortcut to not having to cut and paste or copy and paste this code several times. We can just create the function once and then use it whenever we need it.
My mirror staring back at me, staring back at me.